So, very good evening, dear students. Welcome back to my channel, Chemistry Guru 1993. So, again, we are having a wonderful session with you guys. Today, we are going to record a lecture number 4. Till the lecture number 4, it is already uploaded in the channel. You can go through it and check it. So, this is the new video, Biomolecule. We are discussing biomolecule and lecture number 5 till the lecture number 4 mutarotation. Till the mutarotation we have covered in the last video. Okay, so come to the next video, children, and in this video we are going to discuss about the fructose. So what is fructose? So fructose is also called, it's a kind of ketohexose. It's a kind of ketohexose. What is the meaning? Keto means ketone family. Keto means ketone family. Hex means 6 carbon chain. Ose means sugar. So that is the meaning of ketohexose. So let's talk about the ketohexose, guys. So in that case, what is the straight chain structure? This is the carbon number 1, CH2OH. This is the carbon number 2. In this carbon, we are having oxygen, ketone group. Next carbon, 1, 2, 3, 4, 5, and last carbon, CH2OH. Carbon number 3, here H, here OH, then remaining 2, OH, OH, and here H, and here H. So what is the procedure for beta D fructose and alpha D fructose? So let's talk about the alpha D and beta D fructose. So this is the oxygen which is having lone pair. In that case, this oxygen will attach to the carbon species which is ketone family. This is keto group, and this hydrogen which is free, it will attach with this oxygen. So do it like that. Similarly, so C and CH2OH, this C along with CH2OH, and here OH, this O, and with this H it is OH. Now remaining as it is CH, here OH, then again COH, here H, then C, and then last carbon CH2OH, and this species is having oxygen connected with this. So this is called beta D fructose. This is called beta D fructose. Just like glucose, here also two kind of attack is possible, front attack and back attack. So by the different attack you can get, simply you have to change the position of this carbon, these groups remaining will be same. So how can you change? Here OH, and here CH2OH, and remaining as it is CH, here OH, then C, here OH, here H, here C, here OH, and here H, and here C, and with this C, oxygen is connected with this carbon as it is, and 1, 2, 3, 4, 5. One mistake. 1, 2, 3, 4, 5, 6. Sorry. what happened here? HOH, then OH, and here this carbon. It will be connected with oxygen with this carbon, and here C, and here I forget to attach hydrogen, CH2OH. 1, 2, 3, 4, 5, 6 carbon. So this is alpha D fructose. Alpha D fructose and beta D fructose is formed. Simple. Okay, you can go through it once again. Here, this is the fructose, that oxygen electron attached with the carbon, and that OH attached with this oxygen. Then you are getting beta D fructose here, similarly alpha D fructose. Let's talk about the cyclic structure of fructose. So at the same time, for beta D fructose and for alpha D fructose, it is formed by the 5-membered ring. So this is 5-membered ring. Here oxygen is connected. Here we are talking about alpha. That same thing, right side group, you have to put below. So on the first, second carbon, OH is right side, and here CH2OH. Second, third carbon, here H, then here OH, and here third, fourth, fifth, and here CH2OH, and here H. That is alpha D. Come to the beta D. Similarly, only this carbon, first this carbon position, what I am saying again, you have to change the position of this OH and this CH2OH. So how to change? 5-membered ring, here oxygen, then what happened? Here it will be CH2OH, CH2OH, and here OH is connected. Here as it is H, here OH, here OH, here H, and here H, and here CH2OH. So this is the cyclic structure of alpha D glucose and beta D glucose. This is for beta D glucose, this is for alpha D glucose. Okay, so cyclic structure of fructose we have completed. In that case, that the same thing, it's a sugar also because OH is present, OH. So the naming is done. Now come to the next important part. These fructose are the alpha D fructose, alpha D and beta D fructose are epimers, are they are epimers. Okay, they are epimers. So cyclic structure also completed, alpha D and beta D. They are also known as, once again I am writing, they are both alpha D and beta D. They are formed from organic species furon. What is furon, children? It's a 5-membered ring. connected with oxygen and here double bond. It's called furan. What it's called? It's called furan. Furan, furan. On that basis, this alpha D glucose, also called alpha D, and this is negative sign, alpha D fructofuranose, and this beta, it's also called, what it's called, beta beta D negative fructofuranose. Okay, what is the meaning of negative sign, children? This negative sign means levorotatory. So both are levorotatory. They will rotate in, they will rotate ppl into clockwise. Okay, so this is the condition, children. This is the condition for alpha D glucose and beta D, alpha D fructose and beta D fructose. Okay, so what is the reason behind it? If you want to know, then I can tell you. Because these are the, what they are, in that case we are getting the structure, and that structure, 1 minute, these are structure are called, both structure are called furanose. They both are called furanose, and they are the derivative of fructose. They are the derivative, they are the derivative of fructose. So they are called fructofuranose, fructofuranose, fructofuranose. This is about the naming. Okay, so let's talk about the chemical property. In that case, what is the chemical property is there? Glucose and fructose chemical properties. Okay, now we are discussing the chemical properties. Chemical properties. In the case of chemical properties, children, glucose and fructose generally show similar property. So you can write here glucose and fructose generally show similar reactions, similar reactions. What is written? Glucose and fructose generally show similar reactions. Okay, so in the glucose and fructose, if you remember, they are having, they are having carbonyl group, so they can show just similar reaction to the carbonyl compound. So if you remember, in the carboxylic acid topic we have discussed this thing, alpha hydroxy carbonyls, alpha hydroxy carbonyl are known to show positive known to show positive result for what children, for benedict it's a reagent tolerance and failing test. So, alpha hydroxycarbonyls are known to show positive result for Benedict tolerance and failing test. So, these Benedict if you remember, this tolerance reaction with carbonyl and failing reaction with carbonyl in the carboxylic acid chapter I have covered. You can go through it once and find out the video reaction of carboxylic acid, reaction of aldehyde with tolerance and failing. So basically what they did, they themselves reduced and that carbonyl group get oxidized. That is the work. Okay. So similarly Similarly, glucose and fructose also show positive result positive result with these. Okay. Similarly, glucose and fructose also show positive result with these. So what is the result, children? So that you can go through it and check it. But for the tolerance and benedict is new for us. So for these two, I am writing the equation. You can check it. Here carbon, oxygen, and here hydrogen, and here R. That is the carbonyl group reacting with AgNH3 whole twice and positive. This is your tolerance reagent. So what happened in that case? It will form RCOO minus plus Ag solid. Second case, that same is reacting with benedict Cu citrate CiTrate whole twice. Okay, minus 2, it is also oxidized plus Cu2O solid. So what is the conclusion, children? Here this is reduced. Here oxidation state plus 1 and here silver oxidation state 0. Here plus 2 oxidation state and here plus 1 oxidation state. Check it. Reduction. Here also reduction. It's a Benedict reagent and it is blue color. Benedict reagent color is, what is the color of Benedict? Blue solution. Okay. So these are the positive test. Similarly, tolerance failing also give. It's a theoretical part. You can read it and find out, learn it. Now, the next part, reaction of glucose. Reaction of glucose. In the case of reaction of glucose, first A, reduction. So here CHO, carbon number 1, then second carbon OH left side, third carbon H left side, H right side, OH left side, 1, 2, 3, and both OH right side and CH2OH. It's your glucose. Okay, children. If it is reacting with sodium amalgam, sodium amalgam along with C2H5OH, what is the property? It's a mild reducing agent. It is a mild reducing agent. So what happened in that case? CH2OH, that aldehyde group reduced and remaining as it is. OH, H, OH, OH, H, OH, H, CH2OH. So check it, guys. Here this aldehyde is reduced into alcohol. It's called sorbitol. Okay. Part B, mild reducing agent is only reduced aldehyde group. Part B, same time, same glucose, same glucose you are using, and this time you are using HI and heat. This is a strong reducing agent. A strong RA reducing agent. So what happened in that case? That complete reduction 1, 2, 3, 4, 5, 6. Removal of oxygen, addition of hydrogen. N-hexane. N-hexane formed. Okay. So that is the work of strong reducing agent. Okay, children. That is the work of strong reducing agent. In the case of next, so once again I am telling you reduction by mild reducing agent and strong reducing agent. So mild, that aldehyde reduced into alcohol, and here complete reduction will be done. Complete reduction will be done. Okay. Next reaction at the same time, reaction with HCl, second chemical. Reaction with HCl. Check it, children. Here CHO, OH, at the same time, just like carbonyl compound, it will form cyanohydrin. What? Aldohexose converted into cyanohydrin. Aldohexose converted into cyanohydrin. So how it will form? CN, now 7 membered ring, OH, H, OH, H, H, OH, and remaining 2 OH, H, OH, H, and CH2OH. 1, 2, 3, 4, 5, 6, 7 carbon. Same time, this position you have to change, OH position only. So CN, H, OH, OH, H, H, OH, OH, H, OH, H, and CH2OH. So this is the reaction with HCl. So these are the all chemical property of glucose completed along with fructose. So in the next lecture we will discuss about the sucrose and remaining topics. So this is all for this lecture number 5. Thank you. Please provide your support, like the video, share the video and forward it. Subscribe the channel. This is Govind, your chemistry faculty. Thank you.